Hi, welcome back. Yeah, let's do some covalent nomenclature. Ha! Nomenclature, which just means names. Um, Speaking of names, I'll give you this name because why not? Covalent nomenclature. It can be your word that you may never use again today. Nomenclature means names. Covalent nomenclature is actually relatively easy. Yay! Okay, so covalent bonds do care about those subscripts. We care exactly what they are. Ionic, you will reduce your subscripts to the lowest possible ratio. Covalent, since things are complex, subscripts actually matter. So let's pull that back from recent days in your brain. Subscripts do matter. And let's say are really important, even if they are in a not reduced form. So for example, okay, there you go. For example, this exists, this exists, this exists. Oh, I should make you draw these. Man, that'd be kind of fun homework. Can you figure these out? And yes, you can. Anyways, but some of these have subscripts which, if they were ionic, you would reduce, but since they are covalent, you will not. Do not reduce your subscripts for covalent things, because these are all completely different molecules. Okay, so covalent nomenclature is reflects the subscripts. Okay, and the most likely thing that high schoolers are likely to get wrong in terms of nomenclature and naming things is to put prefixes on ionic things. Prefixes do not go on ionic things. Prefixes do go on covalent things. Covalent bonds, covalent names they explicitly state subscripts. Okay, so let's do these because they're here. And I'll give you some examples, and then I'll give you all the rules, and then you'll be able to just crunch them all. So we kind of write them out. We've got carbon. This is hydrogen. There are 4 hydrogens, so we'll use our prefixes. Let's write that. Covalent names state subscripts as prefixes. Okay, so there's only 1 carbon, great, but there's 4 hydrogens. That subscript is going to become a prefix. 4 hydrogens, prefix is tetra. And this means 4, so carbon with no subscript, this is 1 carbon, 4 hydrogens, and it's got that IDE ending, that means they are stuck together. So it's really just kind of writing the formula as out in words. Subscripts become prefixes in the name. I feel like this is overly confusing already, but let's try a few more and we'll see the pattern. I'm just pulling these examples because why not? Now we want to see we have 2 carbons and 4 hydrogens. 2, the prefix for 2 is di. 2 carbons, dicarbon. And 4 hydrogens. Prefix for 4 is tetra. And hydrogen. And we're going to take off the end and write that IDE ending to show that those things are stuck together. So this is 2 carbons and 4 hydrogens. Last one up here, and then I'll do all the rules. This is going to be a quick video because I imagine that you've seen it and it kind of makes some sense. So C2H2, we want to say that we have 2 carbons, that's not on screen, 2 carbons and 2 hydrogens. So 2, the prefix for 2 is di, 2 carbons, and 2 hydrogens, prefix for 2 is still di, and there's your hydrogens, hydride. Okay, so prefixes, we'll go through 8, just like our charges and our ionic bonds. Prefix for 1, the way to remember this one is the scary toxic gas, carbon monoxide. Mon or mono is your prefix for 1. 2, we just did a whole bunch of stuff with 2 things. So prefixes show subscripts, which are the number of atoms in that molecule. Yeah, so we can even leave this up as an example. 2 carbons, dicarbon, 2 hydrogens, dihydride. 2, the prefix for 2 is di. Prefix for 3 is like a little kid's bike. So this is tri, or the geometric shape, tricycle. Tricycle, triangle. 4 is the one that you are most likely to say quad, which is another like super valid way of saying 4. This is a little bit harder to remember, except there's a game that sounds like this where all of the pieces have 4 squares in them. Tetra is also a word for 4. 5 sounds like a government building. 6 is like your stop signs. 7 is the one that you're most likely to be like, oh, I didn't know that, which is great, you're in the right spot. Not a lot of things use 7, but some do, so we'll do it. And 8 is like the squishy sea creature with lots of legs. Okay, those are your prefixes. And when we use them, one thing you may wonder is, how do I know which atom to write first? It's off the screen. Think of your periodic table like a sentence. Start from the left, work your way across. Whichever thing you bump into first, write that first. Covalent bonds, since everything is in this non-metal, or lots of stuff is in this non-metal section, you can have 2 things in the same column bonded to each other. If you are looking at that kind of a situation, take whichever thing is on the bottom of that column and write it first. But first, like anything to the left, start from left to right. So step 1, left to right. If they're both in the same column, then write whatever is lower first, and then whatever is higher in that column second. Don't worry if you get this wrong. I'm not gonna get real strict on ordering in columns. What I do want you to do is think about left to right, just like counting for your Lewis structures. Whichever atom your pencil crosses over first is the one that you write first. Whichever atom your pencil crosses over second is the one you write second. And just like usual, there is an IDE. Second thing, atom ends in "ide." And you may notice that my 3 examples here are all exceptions. Okay, the exception to this left to right thing, there's always an exception, except hydrogen usually goes last. It's because hydrogen just only ever gets 1 bond, has 1 valence electron, it wants 2. hydrogen can only form one bond, so because of that, hydrogen often gets written last. So all of this stuff, if we were using the start on this side, write whatever your pencil crosses over first method, and then whatever it crosses over second, you would write hydrogen first, then carbon. If you write hydrogen first, then carbon. If you write hydrogen first, then carbon, that's fine. You'll see it written with hydrogen second because we usually think of hydrogen as being the last thing in a molecule because everything else can do more interesting things, and we'll think of those first, and then hydrogen kind of like fills in all the blank spots at the end. It's hard being a single proton, single electron. We just check you on in at the end all the time. But yeah, that's it for covalent nomenclature. I'll do some more examples with your homework video, but prefixes are your key thing. So tell me how much is in your subscript, how many atoms are in that molecule using a prefix. Whichever comes first, write first if you start from left to right. And then your second thing ends in "-ide". Alright, enjoy.